So happy Tuesday to you. We have a quiz tomorrow on, well, Thursday for the odd people, Thursday for the even people, that would be you in class, Wednesday for the odd people, and for you guys online, it'll be posted tomorrow and you'll need to do it tomorrow. Also, 3 worksheets are due. So the first 3 worksheets of the packet, so you'll have to just making sure that it breaks at the right spot. Yeah, it does. So you'll just tear off the first 3 and turn them in. You guys online, take a picture, turn it into one PDF, and submit that PDF. So I don't want 14 JPEG files. I want one PDF. So Google how to do that if you need to. There's plenty of free online converter stuff that will take your pictures and turn them into a PDF. It can have multiple pages, but it needs to be one PDF of the assignment that's due tomorrow. All right, how about questions from worksheet 3? Questions from worksheet 3. Tori. Which one? 14. Average rate of change. Okay, so again, average rate of change, that's more of a vocab word than a new process. It's a new phrase, not a new technique, because the phrase means slope. Yeah, we know how to do slope, hopefully. y2 minus y1 over x2 minus x1. From 0 to 3, so there's my x1 and x2, 0 to 3, which means I need to find f of 3 and f of 0. So f of 3, negative 6 plus 15 would be 9. F of 0 would be 15. So y2 minus y1, 9 minus 15, over x2 minus x1, 3 minus 0. So let's see, negative 6 divided by 3 is negative 2. So my average rate of change is negative 2. Now, I suppose if I had really been paying attention to this problem, what type of graph is this thing? A line. And what's the slope of this line? Negative 2. So it kind of makes sense then that the average rate of change is negative 2. So if I was really paying attention, I might could have answered this question right away and said, well, it's a line, so its slope is always negative 2. But that's not always going to be the case, because we can ask that question with a parabola or a square root or anything else. So that one just happened to be a line. But it was on there so that we could kind of verify that, yeah, sure enough, slope's negative 2. We sort of went the long way around, and yes, slope is negative 2. So average rate of change means the same thing as slope. Probably get you one question on the AP test next year, so you're already ahead of the game. Jason? 10? Let's see. I like that the graph is given to us, so I can answer the questions. I'm going to go. Remember, you can look for the increasing, decreasing, constant pieces first, or you can kind of look at the graph first and just say what's happening. I think I like to look at the graph first and say what's happening. So that piece, that's increasing. And it looks like it maybe stops at negative 3.5 or something like that. But up here, it tells me that it goes forever to the left. So there's not explicitly an arrow on that, but because of how it's defined up here, I know it goes forever that way. So it's increasing from negative infinity to what? 0. Good. Nobody said 3. right? Because these are x values. It increases up to 3, and so it's easy to get confused, but I want to give x values for my interval. So it's increasing from negative infinity to 0. And again, I don't want to include 0 because at 0, that's where it's changing. So I don't want to include 0. The next piece is this flat piece or constant piece. So it's constant from 0 to 2.
It touches 2 though.
It does touch 2, but at 2, it's also increasing on the other side. So basically, we don't want to ever include, on increasing and decreasing intervals, don't ever include the endpoints.
Okay.
Because it's either the end of a graph, and like officially increasing means, the next point over is bigger. Well, that's not really true at 2, or is constant for constant. The next point over is up here, so it's not constant at 2. It's changing at 2.
Okay.
But the basic rule is it's always going to be parentheses for increasing, decreasing, and constant intervals. And then lastly, we're increasing, or wait a minute, yeah, we're increasing, not decreasing. So I can put from 2 to infinity.
Oh, so you don't put a U there?
I do need to put a U there, yeah. And there weren't any decreasing intervals.
So would that mean you'd have to put a U on 8 as well?
So 8 is going to have multiple increasing intervals, yes. Yeah.
Anything that has multiple, I mean, you just need a U in between.
Correct. The U means include all of these intervals. It's just like the math way of saying and. Yeah, this and this.
If we don't throw that U in, are we wrong?
Technically, yes, but that's such a minor thing, I'm probably not going to take off. I might take off 1 point 1 time for the whole, if it happens 3 times and you always leave it off, I might take off a point. Because it's not that big a deal, but it's technically part of the answer. Ty? Number 3. The x-intercepts. X-intercepts. Let's see, that's the same thing as roots and zeros. So 1, 2, and 3 are kind of the same question. We tried to just use different words. Find the zeros. Where is it cross the x-axis? Find the x-intercepts. That all means the same thing. And it all means x-intercepts would be, I don't know what they are, but they would be where the y is equal to 0. So 0 equals 12 minus x squared over 5. And I think we talked about this yesterday. There's sort of 2 ways to think about that. You can think fractions, the only way to make a fraction 0 is if the top is 0. And so you can just say, well, the 5 doesn't matter. Or if you're more straightforward, I need to follow the process and multiply both sides by 5. We can do that. And we end up at the same spot. So if you can sort of mentally justify why you're throwing away the 5, that's fine. If that bugs you and you want to multiply both sides by 5, you land at the same place. Let's see. I think I'll move the x squared over to make it positive. And then I'll square root both sides. But when you put the square roots on, you've got to remember the plus or minus. Now, you probably would have remembered that for this particular problem because all of the answers have plus or minus. So it's not likely you'd miss that for this problem. I don't see square root of 12 as an answer. Why not? Yeah, it's not simplified. So I could break that into 4 and 3 and get 2 square roots of 3 with the plus or minus on there. And so that looks like answer choice A. Good question. Covered a lot in that one question. Anything else? So roots x-intercepts, zeros, kind of got that. Intersections like 4 and 5, but that's ends up being just to solve the equation thing. Roots again, increasing, decreasing, constant. We did one of those. A couple of calculator questions. Another average rate of change question. Pretty straightforward, I guess. So this is the last thing that'll be due tomorrow. So today we'll talk about what's on worksheet 4 and we'll assign worksheet 4, but worksheet 4 is not due tomorrow. So due on, well, I keep saying tomorrow. Due on Thursday is worksheets 1 through 3. So you will have to tear them apart, and depending on where the staple lands, you might need to borrow a stapler to reattach one of the pieces, and then turn in 1 through 3.